Good morning, I am Pramod Kumar Srivastava, Professor, TMIT, TMU. My subject is Business Research Methodology. In Business Research Methodology, today I am going to discuss on the topic of dispersion, correlation and the regression. So, learning outcome. After going through this lecture, you will be able to understand how you can measure the dispersion or how you can describe the dispersion, and you can understand the spread and the validity of the data. Correlation measures the strength and the direction of the linear relation between the two variables, and the regression analysis estimate the relation among the variables. So, these are the outcome of this lecture. So, you will be go through this lecture, you will be able to understand the concept of dispersion, correlation and regression. Next is the measurement of dispersion. The average are representative of the frequency distribution, but they fail to give a complete picture of the distribution. They do not tell anything about the scarceness of the observation within the distribution. So, simply when we are going through the measurement of central tendency, and there are the three important measurement in measurement of central tendency: mean, median, mode. In measurement of central tendency, we just get the data. Suppose through the mean we can understand that the average of the data, average value of the data. From median we can understand that we can divide it whole data into the more than that median value and the less than that median value, means the division of data into the two part. So, through mode median we can split the data into the two part. Mode is giving that which value have a higher frequency in the data, but by mean, median, mode we are not able to understand that which value is what is the main characteristics of data, how data is scattered. Simply if data is whole value of the data is same, suppose that if I want to calculating the mean value of the 100 students getting a score in the mathematics marks, and every student getting 40 numbers in the mathematics marks, then we are calculating the mean value, the standard deviation, we are calculating the average or the mean value, that is the 40, because every student get the marks in the mathematics examination is 40. So, at that situation the average is 40, but in some situations some student pass, some student fail, some student score very high marks, some student score very low marks, and after that the average become a 40. So, in the both data we can see that the how both data, one data is very similar data, very nominal data, but on the other case the next other data is considered as in the very abnormal data, data is very scattered data. So, how data is scattered? So, we are measuring in dispersion the scarceness of data, how they are scattered in various way. So, suppose that we have to distribution in the yield a key Ag per plot of the two PD varieties from the 5 plot each. The distribution may be are as follows. Here there is the example in this slide. So, the average are represented of the frequency distribution, but fail to give a complete picture of the distribution. They do not tell anything about the scarceness of the observation within the distribution. So, here we have two variety of the PD and their yield rate is given here. So, variety 1 45, 42, 42, 41, 40, variety 2 54, 48, 42, 33, 30. So, by this example we are able to understand that you can also see this thing in this slide, how these two varieties are scattered in that way, and how we are going to understand the scatteredness of the data or scatteredness of the observation. It can be seen that the mean yield of the both variety is 42 kg, but cannot say that the performance of the two variety are same. There is a great uniformity of the yield of the first variety, whereas there is the more variability in the yield of the second variety. So again I am showing you that there is in the variety 1 and 2, and the mean value of the both variety is 42, but the first variety is showing the uniformity. On the other hand, the second variety is showing the variability. So we can compare that two varieties have a different scarceness. First variety giving you a uniformity value and the second variety is giving you a variability value, but the mean value of both is the same. So through mean we are not able to understand that the uniformity and variability of the data. So if you want to understand uniformity and variability of data, you have to go through the dispersion. The above example, it is obvious that the measure of the central tendency alone is not sufficient to describe a frequency distribution. In addition to it, we should have a measure of scarceness of the observation. The scarceness or the variation of the observation from their average are called the dispersion. So what from the average what data and how much data is scattered or various variabilities, that is known as the dispersion. So such simple meaning or the literal meaning of the dispersion is how data is dispersed from the mean value. So if data is dispersed less from the mean value, then we can say that the uniformity in data, if the data is highly dispersed from the mean value, that is called the variability of data. So simply in a dispersion we are measuring the uniformity and the variability. So again I am repeating that if the data is small dispersed from the mean value, that means it is a uniformity and the data is a uniform data, and if data is a highly dispersed from the mean value, that is called data is variable data or data is highly variable data. So through the dispersion we can calculate the uniformity and variability of data. Next, the characteristics of good measurement of the dispersion. Here there are some ideas of the dispersion. So first it should be rigidly defined. So whatever we are defined about the dispersion, it should be rigid in definition. It should be based on all the item, whatever the item, every item in the data, on that basis we are calculating the dispersion. It should not be unduly affected by the extreme item. So whatever the extreme item in our data, the value is not affected. It should lend itself to algebraic manipulation, and it should be simple to understand and easy to calculate. So these are the certain characteristics of the measurement of or the good measurement of dispersion. Again I am repeating: the rigidity based on the item and less affected with the extreme value, algebraically manipulations, and the last one is it is easy and easy to understand, and it is also easy to calculate. So these are the characteristics of the good dispersion. Next is in the range. So this is the simplest possible measures of dispersion, and it defines the difference between the largest and smallest value in the variables. So whatever the values in your observation or the variables value, through range we can want to calculate the smallest and the highest value in the observation or in the data. So where L stands for largest value and S stands for smallest value. So through range just we are creating understanding of the smallest and the largest value in the observation or in the data. In individual observation and the discrete series, L and S are easily identified, but in continuous series the following two methods are followed. So simply in discrete series it is very easy to identify L and S, largest value and smallest value, but in a continuous series there are two methods, and the methods are as follows. First one is method 1. So in the method 1 the upper boundary of the highest class and the lowest boundary of the lowest class. So method 1 we are using the upper value of the highest class and the lowest value of the lowest class. By this we can calculate the range. Suppose if we have a value from 10 to 100. So from 10 to 20 the lowest boundary, and to 90 to 100 is the highest boundary. So in lowest boundary we are using the lowest value. So in the lowest boundary 10 to 20 the lowest value is 10, and in the highest boundary 90 to 100 the value is 100. So we are selecting the range 10 to 100. 10 is the lowest value or the smallest value, or 100 is in the highest value. So 100 stands for the large upper boundary and the S stands for the small boundary, that is 10. So method 2 is calculating the mid value. So in the calculation of the mid value, suppose we started the lowest boundary is 10 to 15 and highest boundary is 80 to 90. So mid value for the lowest boundary is 15 and the highest boundary is 85. Mid not 85, 95. So this is the way we are calculating through method 1 and method 2 the lowest and the highest boundary, and through getting the lowest and highest boundary we can calculate the range from the data. So here also there is an example given. The yield rate, already we go through the cotton variety from the 5 plots are 8, 9, 8, 10 and 11. So this is the yield rate of the cotton variety of the different plot. So same cotton variety using on a different plot, and their yield rate is 8, 9, 8, 10 and 11. So solution is L is the largest value. So here the largest yield rate is 11 and S stand for the smallest value. The smallest value is 8. So range is 11 minus 8, L minus 8, that is the 3. So by this way we can calculate the range. On the other example, we are calculating range from the following distribution size. So in the following distribution size started with the 60 to 63, 63 to 65, 69 to 66 to 69 and 69 to 72, 72 to 75 and their corresponding frequency given below. So solution is the upper boundary, the highest class is 75. So just we are taking a upper boundary 75 and the lowest boundary lowest value is in the lowest boundary, the lowest value is 60. So now 75 minus 60, that is the 15. So range is 15. And there are certain merits of this range. It is the simplest to understand. Range is very simple mathematical calculation or very simple calculation. It is very easy to understand for anyone. It is easy to calculate. We are using the simple mathematical calculation, just it is very simple mathematical calculation, that's why it is very easy to calculate. And the third is, in certain type of problem like the quality control, weather forecast or share price analysis, we can use. So range is most widely used. So usability of range is most vital usability. Next is on the demerits. So there are certain demerits of the range. It is very much affected by the extreme items. So if the extreme value is very different, so it will affect, because extreme value affected the range values. It is based on only two extreme observations. So when we are calculating the range, just we have only two extreme, and one is the lowest and another is in the highest. And if the dispersion of lowest and highest value is very high, that makes a very high value for the range. It cannot be calculated from open end class interval. Sometimes there is in the open end class interval, at that situation it is very difficult to calculate. It is very rarely used measurement. So again we are saying that the it is rare use measurement considered. So these are the demerits of the range. Next is in the standard deviation. So a standard deviation is defined as in the positive square root of the arithmetic mean of the square of the division of the given observation from their arithmetic mean. So standard deviation is denoted by the sign of S small, or also it is denoted by the sign of the sigma. So standard deviation, popularly a standard deviation denoted by the sign of sigma, and the formula of the calculating a standard deviation is given in this slide. The root square of sigma x square minus sigma x under root square divided by n and divided whole n minus 1. So through this we can calculate the standard deviation for the row data and the group data. So there are certain differences in the standard deviation formula. For the discrete data we are using this formula, that is, and for the continuous data we are using this formula. So there is slightly differences, and where for the class interval D is equal to x minus a divided c, and c stands for the class interval. So this is the formula of the standard deviation, and there are some merits of the standard deviation. It is rigidly defined and its value is always defined and based on the observation, and the actual sign of the deviation are used. So standard deviation uses the sign of deviation, and that is the actual sign of the deviation. As it is based on the arithmetic mean, it has also the merits of the arithmetic mean. So standard deviation always based on the arithmetic mean or the mean value of the data. So if you want to calculate a standard deviation, first you have a knowledge of mean, or sometime the mean value is given in the question. It is the most important and widely used measure of dispersion. So under the family of dispersion, standard deviation is most useful measures, and it have immense utility. It is possible for the further arithmetical treatment or algebraical treatment. So for further algebraical treatment required, we are using the standard deviation. It is less affected by the fluctuation of sample and hence the stable. So sometime there might be the fluctuation on sample, and due to the fluctuation of sample also it is less affected. So simply we can see that standard deviation is very stable measurement in statistics. It is a basis for the measuring of coefficient of the correlation and sampling. So for the calculation of coefficient of correlation, we are using standard deviation. So on the basis of standard deviation, we can calculate coefficient of correlation. So these are the major merits of the standard deviation, but certainly there are certain demerits of the standard deviation. That demerits here you are seeing in this slide. It is not easy to understand and it is difficult to calculate. So simply the other calculation or calculation of mean or calculation of a range, it is very difficult to calculate, and without proper knowledge you are not able to calculate the standard deviation. It gives you more weight to extreme value because the value are squared up. So sometime for the extreme value it is giving the more weightage because we are squaring the formula, and as it is the absolute measurement of variability, it cannot be used for the purpose of comparison. So it is used for the understanding of the variability of the observation or data. That's why it is not used for the purpose of the comparison. So we are not using standard deviation for the purpose of the comparison of the data. Next is on the variance. The square of the standard deviation is called variance. So standard deviation square root is called variation. Next, the coefficient of variation. The standard deviation is an absolute measurement of dispersion. It is expressed in terms of unit in which the original figure are collected and stated. The standard deviation of the height of the plant cannot be compared with the standard deviation of weight of the grain, as both are expressed in the different unit. So height in the centimeter or weight in the kilogram. Therefore the standard deviation must be converted into the relative measurement of the dispersion for the purpose of comparison. The relative measurement is known as the coefficient of variation, and the coefficient of variation is obtained by dividing the standard deviation by the mean and expressed in the percentage. Symbolically, coefficient of variation CB is standard deviation divided by mean multiplied by 100. So simply for the purpose of the comparison, and when we are using the two different measurement for measurement tools, at that first we have to convert the measurement tools into a similar measurement tool, and then we can calculate. So for the purpose of the calculation of coefficient of variation, standard deviation is very prominent tools in the statistics. So coefficient of variation, if we want to compare the variability of the two or more series, we can use CB. So for understanding purpose or for the comparison purpose, for two or more series, we are using the coefficient of coefficient of variation, and to understand how the different series are dispersed differently and how the different series are different from one another. If the coefficient of variation is less, it indicates that the group is less variable and its coefficient of variation is more uniform or more consistent and more homogeneous. So value of coefficient of variation provided you that the variability of the different series. If the value of coefficient of variation is very less, that means there is the uniformity in the uniformity in the series, or uniformity of comparing, when we are comparing from one to another series, we can say that there is the uniformity in the series. So lower value of the coefficient of variation providing you the understanding of the uniformity in the series, and the higher value of providing you the understanding that the variability of the different series. Next is correlation. In previous chapter we have to learn how to construct summary measurement out of the masses of the data and changes among the similar variables. Now you will learn how to examine the relation between the two variables. So in a correlation, just we are going to examine the relation between the two variables, how two variable is positively correlated, means that there is the positive relation between the variables, and there is the negative relation in the variable, or there is no relation between the variable. So simply correlation giving you a relationship between the two variable and how two variable is related with one and another. So as the summer bit rises, as the summer heat rises, hill stations are crowded with more and more visitors. Ice cream sales become more bricks, and thus the temperature is related to the number of visitor and sales of ice cream. Similarly, the supply of tomato increases in your local mandi, its price drop. When the local harvest started reaching in the market, the price of the tomato dropped from the pricely 40 price to the 4 rupees price per kg. Thus the supply is related to the price. Correlation analysis is a mean of examining the such relation systematically. It deal with the questions such as, so simply we can say that the correlation is giving you a relation between the two variable, like in the example, as much as increase rises in the heat, that increase in the sales of the cold product like ice cream or the cold drink or the cold tea or the cold coffee, and also the cold drinks or different cold beverages. And on the other hand, the increase in the production, so decrease in the price. So simply we can say that if the product supply is increases, the product price is decreases. So supply and price, there is in the inverse relationship. So by this way we can understand that how correlation is important to understand the relation between the different variables. So sometime there is in the positive relation, sometime there is in the inverse relation. So increasing heat, increasing the demand for the ice cream, that means we can say that there is in the positive relation between the increase in the temperature and increase in the sale. But on the other hand, sometimes we can say that increase in the heat that might be with the decrease in the product like in the hot product, because in the summer people like to drink cold product in respective of the hot product. On the other hand, in the when the temperature is decreases, we are demanding for the hot product. So cold coffee is sale high in the summer season and hot coffee sale increases high in the winter season. So these are the certain relation through the example we want to explain how there is in the relation between the variable, and in the correlation just we are mapping the difference relation between the variable and how one variable is varies with the another variable. It varies in the positive direction or it varies in the negative direction, or we can say that there is no variation of the two variables. So you can see there are the relation between the variables. So here we can see that there is no variation in the variables. By this picture we that make you the understanding of the, but in the second picture, if the value of one variable changes, does the value of the other variable also changes? So because through the picture we are this picture just I am trying to create you a better understanding regarding the concept of correlation. So further slide also giving you the picture. Do the both variables move in the same direction? So in the last picture you can see that the both variable moving into the opposite direction, but in the third picture we are going to see that both are moving into the same direction. So in the first picture there we can see that there is no correlation. In the second picture there is in the negative correlation. In the third picture there is in the positive correlation. So by this picture I am trying to give you a better understanding regarding the two variables, how two variable is correlated with one another, and there is in the three possibilities. One is there is in the no correlation between the variable, and second possibility is there is in the negative correlation between the variable, and the third possibility is there is in the positive correlation between the variables. So these are the three relation between the variable, and that three relation established by the correlation concepts. So next slide is types of relationship. Let us look at the various type of relationship. The relationship between the movement in the quantity demand and the price of the commodity in a general part of the theory of the demand. Lower agriculture productivity is related to the lower rainfall. So simply we can say that the lower productivity relate with the lower rainfall. That means there is the positive correlation between the variables. If the higher rainfall, it create a higher productivity in the agriculture. So such example of the relation may be given in the case and the affected interpretation. Other may be just coincides. The relation between the arrival of the migratory birds in the century and the birth rate of the locality cannot be give any cause and effect interpretation. The relation are simple consideration and relation between the size of the shoes and the money in your pocket is another such example. Even if the relation exists, they are the difficult to explain. So sometimes some relation is difficult to explain. We cannot able to explain the amount of money in your pocket and the size of your shoes, because there is no any establishment of relation of the size of shoes with the amount of the money. But we can establish the relation between the amount of money in your pocket and price of the shoe. In another example, a third variable impact on the two variable may give a rise in the relation between the two variable. Brick sale of the ice cream may be related to the higher number of death due to the drowning. The victim are not drowning due to the eating the ice cream. So rising temperature lead to the brick sale of the ice cream. Moreover, the larger number of people started going to swimming pool to beat the heat. This might have raised the number of death by drowning. Thus, the temperature is behind the high correlation between the sales of ice cream and the death due to the drowning. So sometime there are some extraneous variable that also impacting, and their impact is very different manner. So sometime the two variable is giving a very good big picture about their relation, but the other variable is not giving you a better picture about the incidence. Like example of people death due to increase in the temperature, because when the higher temperature due to people going to the swimming pool or the river or any nearby their pond. to reduce the impact of the temperature, and due to that reason there is the increase in the death of the person. So sometime some variable have giving a very good picture about their relation, but sometime the other variable not giving you the better picture about some variables. What does correlation measures? So correlation studies and the measure the direction and intensity of the relation among the variable. So simply through the correlation we can able to understand the direction and intensity of the relation between that variables. So correlation should never be interpreted as implying cause and effect relation. So in correlation we cannot imply the cause and effect relation, just we can understand the direction and intensity of the relation between the variables. The presence of correlation between two variables x and y simply mean that when the value of the one variable is found to change in one direction, the value of the other variable is found to change in the same direction, that is called positive correlation. Means those variable value is changing in the same direction, that is called positive correlation, but sometime one variable changes in one direction and the other variable value, and sometime there are no changes between the variables. So there is called there is no correlation between the variables. Types of correlation. So correlation is commonly classified into negative or positive correlation. So generally we can say that there is the positive relation or there is negative relation. On that basis we can say that the positive and negative correlation. The correlation is said to be positive when the variable move together in the same direction. So simply when two variable moving into the same direction we can say that there is the positive correlation between the variable, but on the other side there might be the variable moving into the different direction, that is called negative correlation. When income rises, consumption also rises. So we can say that there is the positive correlation between the income and consumption or income and expenditure. Suppose that if the person income is increases, their expenditure is also increases. So we can say that there is the positive correlation between the income and expenditure or the positive correlation between the income and consumption. So sales of ice cream increases as temperature increases. So also we can say that the sales of ice cream and the temperature have a positive correlation. The correlation is negative when move of the opposite direction. When the price of the apple fall, the demand increases. When the price rises, its demand decreases. When you spend more time in a study, changes of your falling decline. When you spend less hour in your study, changes of the score is low, marks and increase a grade. These are the instance of the negative correlation and the variables move in the opposite direction. So sometime variables moving in the opposite direction, and that means we can say that there is the negative correlation between the variables. So technique of measuring the correlation. Three important statistical tools used to measure the correlation are scatter diagram, Karl-Pearson coefficient of correlation and Spearman rank correlation. So simply there is two major important tools for measuring the correlation, or we can say that there is a three important technique of measuring the correlation: a scatter diagram, Karl-Pearson coefficient of correlation and the Spearman rank correlation. The scatter diagram visually presented the nature of the association between giving any specific numerical value. The numerical measures of the linear relation between the two variables is given by the Karl-Pearson coefficient of correlation. A relation is said to be linear if it can be represented by the straight line. Spearman coefficient of correlation measure the line association between the rank assigned to an individual item according to its attributes. Attributes are those variables which can be numerically measured, such as intelligence of the people, physical appearance and the honesty. So these are the attributes we can be measure on the numerical values, or we cannot give you a numerical value of the intelligences or the physical appearance or the honesty of the human being. Next is in the scatter diagram. The scatter diagram is useful technique for visual examining the form of a relationship without calculating any numerical value. In this technique, the value of the two variables are plotted as the point on the graph paper, and from a scatter diagram one can get a fairly good idea of the nature of relation. In a scatter diagram, the degree of closeness of the scattered point and their overall direction enable us to examine the relationship. If all the points lie in the same line, there is the correlation perfect and said to be the unity. And if the scatter diagram is widely spread around the line, the correlation is low. The correlation is said to be linear if the scatter diagram is lie near the line or on the line. So these are the way we can understand that the relation between the two variables through the scatter diagram method. And in a scatter diagram method, just we are pointing the value of the two variables. A scatter diagram show a scatter around an upward rising line indicating the movement of the variable in the same direction. When x rises, y will also rise. This is the positive correlation. The point where found that the scatter diagram is downward sloping line. This line is the variable move to the opposite direction. When the x rises, y fall, or vice versa. This is the negative correlation. There is no upward rising or downward sloping a line around which the point are scattered. This is an example of no correlation. So we can simply say that there is no any relation established between the variable. The points are no longer scattered around an upward rising or downward falling. The point themselves are on the line, and this is prefer to a perfect positive correlation and perfect negative correlation. And careful observation of the scatter diagram give you an idea of the nature and intensity of the relation. So simply we can understand that through the scatter diagram that the region the positive correlation or negative correlation, or there is no correlation, or perfectly positive correlation or perfectly negative correlation. Karl Pearson coefficient of correlation. This is also known as the product movement correlation and simple correlation coefficient. It gives you the precise numerical value of the degree of linear relation between the two variables. So Karl Pearson correlation provide you a understanding of the linear relation between the two variables, and that variable is x, y. The linear relation of the value is given as y equal to a plus b x. So this type of relation may be described by the straight line, and the intercept that the line make on the y axis is given by a, and the slope of the line is given by b. So a b stands for, here given in this description, it gives the changes in the value of the y for very small changes in the value of the x. On the other hand, the relation cannot be represented by the straight line as in y is equal to x2, the value of the coefficient will be 0. it clearly showed that the zero correlation need not mean absence of any type of relation between the two variables. Let us x the value and the y value be corresponding value of the y. In the subsequent presentation, the subscripts indicate that the unit are dropped from the sake of simplicity. The arithmetic mean of x y are defined as sigma x x bar is equal to sigma x divided the n, means the number of the item of x, or the sigma y y bar is equal to sigma y divided by the n, and their variance are as follows. So sigma x bar and y bar. Next we can see that by the graphical presentation that this is the example of the positive correlation, and that is by the scatter diagram method. And the next giving you the negative correlation. Then every point on the same line and showing that the upward movement, that's why it is called a perfect positive correlation. And the next is and the perfect negative correlation is because the whole point on the line and showing the downward direction, so that is called perfect negative correlation. And here we can see that there is no correlation. So this is the example of the scatter diagram method. So here Karl Pearson coefficient of correlation formula is given. How we are going to calculate coefficient of correlation? Before calculating the coefficient of correlation, first we go through the calculation of the standard deviation, and by putting in the value in this formula we are able to calculate the, or we can calculate the coefficient of correlation, and this is the formula of Karl Pearson coefficient of correlation. So in calculation of the coefficient of correlation, first we have a knowledge of the mean value or the knowledge of the arithmetic mean, because coefficient of correlation is calculated on the basis of arithmetic mean. So first if you have a data and if you do not know the arithmetic value or the mean value, but you have a data on that basis, first you have calculate the arithmetic mean, and sometime the arithmetic is given in the question, and on the basis if the arithmetic mean is given in the question, on that basis we can also calculate the coefficient of correlation. Between x and y determine the sign of the correlation coefficient, and the standard deviation are always positive. If the covariance is 0, the correlation coefficient is always 0. Their product moment correlation and the Karl Pearson measurement correlation is given below. Next is in the properties of coefficient of correlation. Let us now discuss the properties of correlation coefficient. R has no unit. It is a pure number and mean that the measurement are not part of R. R between height in feet or weight in the kilometer, for instance, could be say 0.7. The negative value of R indicates the inverse relations. A change in one variable is associated with the change in the other variables. At demand fall, when the rate of interest rises, the demand for the fund also fall. So we can say that rate of interest and the demand for fund have a negative relation, because increase in the interest rate, demand for fund is decreases, and if the interest rate decreases, demand for fund is increases. So it is because now funds have become costlier. If R is a positive, the two variables move in the same direction. When the R price of coffee, the substitutes of tea rises, the demand for the tea is also rises, and improvement in the irrigation facility is associated with the higher yield rate. When the temperature rises, sales of ice cream become rises. So these are the value of the positive correlation. So simply the correlation value lie between -1 to 1. So this is the correlation value. So when we are talking about the value of the correlation coefficient, so the correlation coefficient value is lie between -1 to +1. If you are getting value more than 1, that means there is a fault in the calculation. So simply you can make understanding, or you have to focus in this, that the value of correlation does not increases more than 1. So simply we can see that the value of correlation lies between -1 to +1. If R0, the two variables are uncorrelated. So if the value of R is 0, if you found that value of R is 0, that means there is no correlation. If the value of R is 1, that means there is in the perfect positive correlation. If value of R is -1, that means there is a perfect negative correlation between the variable. So if R equal to 1 and R equal to -1, correlation is perfect. So when value of R is -1 or the +1, means the correlation is perfect. Either it is negative correlation or it is positive correlation. A higher value of R indicate the strong linear relation, and the value is said to be higher when it is close to 1. So simply we can say that if the higher value of R giving you idea of the strong linear relation, and if we can say that if the +1 or the -1 or value nearby +1 or -1, we can say that there is a strong linear relation. It might be the positive or it might be the negative. A low value of R indicated get weak linear relation. So simply if value of R you are finding very low, it is called there is the weak linear relation, and value is 0, then we can say that there is no correlation. The magnitude of R is unaffected by the change of the origin or change of the scale. So whatever the magnitude of R, that is not affected with the changing in the origin or changing in the scale. So it is also make understanding that the origin of a scale or origin or change in the origin of a scale or change in the higher value of R indicate a strong relation. Always we go with this slide, and the low value providing you the low relation between the variables, and if the value lies on the nearby 1, either it is positive 1 or it is a negative 1, that means we can say that in the perfect correlation or the very strong correlation. Or if the value is -1, that means the is in the perfectly negative correlation, and if the value is +1, that means there is a perfectly positive correlation. So magnitude of R is unaffected by the change in origin and change in scale, and the given variable x, y. Let us define two new variables here in this slide, where A and C are assumed mean of the x and y respectively, and B and D are commonly common factor and the same sign. Then R is equal to XR equal to XUV. So properties of further properties of correlation is used to calculate the coefficient of correlation in a high simplified manner as it is in steps. So deviation method, next point is a deviation method. As you have learned in this chapter 1, the statistical method are no substitute for the common sense. Hence the another example which highlight the need for understanding the data properly before the correlation is calculated and interpreted. In epidemics spread in some village and the government sent the term doctor to affect the village or calculate the how that epidemic is affected in the village. The correlation between the number of death and the number of doctors sent to the village is found to be the positive. Normally, the health care facility provided by the doctors are expected to reduce the number of deaths, showing that the negative correlation. So, we can say that if the increase in the rate of doctor and death rate is decreases. So, death rate have a negative correlation with the doctor. So, as much as we want to decrease the death rate, we have to increase the numbers of doctor. So, data reduce the specific item period and any of the reported death could be terminal cases where the doctor could do little. So, sometime increase in the doctor, but we are not able to decrease the death rate. That means the doctor is not working their job in an effective manner. Moreover, the benefit of the presence of the doctor become visible only after some time, and it is also possible that the reported death are not due to the epidemic, and the Tasmanian suddenly hit the state and death toll rises. Third type of correlation is Spearman rank correlation. Spearman rank correlation was developed by the British psychologist E.C. Spearman, and it is used when the variable cannot be measured meaningfully, as in the case of price, income or weight, etc. Ranking may be more meaningful when the measurement of variable are suspect. Consider the situation where we are required to calculate the correlation between the heights and the weight of the student in the remote village. Neither missing roads nor a weight scale are available. The students can be easily ranked in terms of height and weight and without using measuring rods or the weight scales. So, sometime Spearman rank correlation is very effective in the if the data is in a qualitative data, like we are talking about the if you are going to measure the intelligence level or the physical appearance of any person, and sometime if you want to measure the height of the student or the weight of the student, but at that situation if you haven't any measuring tools, so you can use rank correlation, and through the rank correlation we can identify that which student have a higher height and which student have a lower height. So, on that this is the importance of the rank correlation, Spearman rank correlation. There are also situation when you are required to quantify qualities such as the fairness, honesty or intelligence. Ranking may be better alternative of the qualification of the qualities, or sometime if you want to calculate the intelligence level or calculate the honesty level. Rank correlation coefficient or the simple correlation coefficient have the same interpretation. Its formula has been derived from the simple correlation coefficient, where the individual value have been replaced by the rank. These rank are used for the calculation of correlation. This coefficient provide a measure of linear association between a rank assigned to these units and not their value. So, simply Spearman rank correlation is mostly used for when we haven't there is the absence of measurement tools. So in the situation of absence of measurement tool, we are using the rank correlation methods, or sometime if you want to measure we are also using the rank correlation method. So here it is the product moment correlation between the rank. Its formula is given of the rank correlation, where the n is the number of observation, d is the deviation of rank assigned to the variable from those assigned to the other variables, and when the rank are repeated in the formula is where m1 m2 or dot are the number of repetition of the rank, and the m1 plus m2 divided by the 12. So corresponding correlation factor, the correlation is needed for every repeated value of the both variable. If 3 values are repeated, there will be a correlation for each value. Every time indicate the number of item in the value is repeated. All the property of the simple correlation coefficient are applicable here, like a Pearson's coefficient of the correlation. It line between 1 to 1 minus 1 plus 2 minus 1. However, generally it is not as accurate as the ordinary method. This is due to the fact that all the information concerning the data is not utilized. The first differences of the value of the item in the series arranged in order of the magnitude are almost never constant. Usually the data cluster around the central value with the smaller difference in the middle of the array. If the first differences were constant, then R and the R would give a identical result. The first differences is the differences of the consecutive value. Rank correlation is preferred to Pearson's coefficient when the extreme value are present. In general, Rk is the less than or the equal to R. The calculation of rank correlation will be illustrated under 3 simulation. The rank are given, the rank are not given. They have to work out from the data, and rank are repeated. So there is in the 3 situation. On that basis, we are illustrating the rank. So conclusion, we have discussed some technique for studying the relationship between the two variables, particularly the linear relation. The scatter diagram give you the visual presentation of the relationship, is not confined at the linear relation. Carl Pearson coefficient correlation or the rank correlation measure the linear relation among the variable when the variable cannot be measured precisely, and the rank correlation can be used. These measure however do not apply caution. The knowledge of the correlation give us an idea of the direction and the intensity of the changes in the variable when the correlated values variable changes. So simply we can see that correlation is giving you an idea between the variability and uniformity of the uniformity relation between the variables. So how variable is perfectly relate, or how variable is imperfectly relate, or how variable there is no relation. Regression. So regression analysis, the relation between the dependent and independent variable is often repeated using the regression line. This line is described by the mathematical equation. Let us break down the key component and equation for the different type of regression line. Simple regression, and the equation given y is equal to mx plus by equal to mx plus d. So this is the simple equation. Component of the regression. So y dependent variable, outcome you are predicting, x is then the independent variable that is predict, and the m is equal to ob1, the slope of the line represent the changes in y due to 1 unit changes in x. So beta represent you slope of the line, and where the b is equal to beta 0, y intercept the value of y when x is equal to ox. Simple linear regression, we have dependent variable y and one independent variable x. The relation is modeled with the straight line given by the equation. So y is equal to b0 b1 x. So here already we talked to y is the dependent variable, x is the independent variable, y dependent variable, x independent variable, b0 interception the value of y when the value o is 0, and b1 the slope changes in the y as 1 unit changes in the x. So this is the formula of the simple linear regression. Next, the interpretation. The point where the regression line crosses the y axis and it represents the predicted value of y when x is 0, and the slope is b indicate that the rate of changes in the dependent variable for each unit changes in the independent variable. Interceptions. b0 the point where the regression line crosses y axis and it represents the predicted value of y when the x is 0, and the slope is b1 indicate the rate of changes in the independent variable for each unit changes in the independent variable. Next, multiple linear regression. In multiple linear regression there are multiple independent variable and the equation is extended as follows. So simply in the multiple linear regression there are the multiple independent variable, and here the variable you can see that is expressed by beta 0 beta 1 to extend to the bn. So how we can increase the independent variable, and increase in the independent variable that is part of the multiple linear regression, and the formula of the multiple linear regression here given, and the dependent variable is y. Next is in the regression line. Regression line is a graphical presentation of a regression equation. It shows that the best fit line through the data point in a scatter plot, and this line minimizing the sum of the square differentiation or residual between the observed value and the predicted value. So calculation, the coefficient is given here, and by this coefficient you are calculating the example. Suppose we have data on the number of hour studied x and the corresponding test score y of the student. We can use the linear regression to model the relationship. The test score is b0 plus b1 multiplied by hours study. If we find that the intercepts b0 is 50 and the slope b1 is 5, the equation value is 50 plus 5 multiplied by hours, So finally, the hours study, the mean in of the every additional hour study, the test score increases by the 5 points. So simply we can see that every hour of studies we can increase the test value by the 5 points. So this is giving you a relationship between the score and the test study. And the visualization of the regression line in a scattered plot of the data point, the regression line can be drawn to show the relationship between the variable and close the data point are to the line, and stronger the relation between the variables. Representation of the regression. The regression line is the straight line that minimize the sum of the square differences between the observed value and the predicted value. So simply in a regression we are predicting on the basis of the value. Application of predictive analysis. So prediction of the value is dependent variable based on the independent variable. Trend analysis, identify trends and making forecasts, and cause and effect relation, understanding how changes in the independent variable affect the dependent variable. So simply in a regression analysis we are able to understand that how we can predict the value of the dependent variable based on the independent variable. So through regression we can predict the dependent variable on the basis of independent variable, and also we can understand that to identify the trends and the how we can forecast on a particular event or particular activity. And third point is in the through the regression we can understand that cause and effect relation between the variables. So simply we can say that we go through the three methods, the dispersion, and dispersion. Through dispersion we can understand that the how data is dispersed. It is data is uniform data, or the data is very much scattered, or data is scattered data or uniform data. But in correlation we are able to understand that the relation between the two variable, how one variable changes and that make the changes in the another variable, or we can say that is there is any changes between the variables. So by this way correlation we can understand the relation between the variable, but by the regression we can understand the prediction, how we can predict the dependent variable on the basis of independent variable. So regression is also using for the forecasting when we are forecasting the dependent variable, or also we want to understand the cause and effect of the independent variable, we are using the through dispersion. We just understand that how data is dispersed, how there is in the relation between the data, and how we can forecast dependent variable on the basis of independent variable. I want to make you a better understanding about the dispersion, how dispersion is. So first thing is that through dispersion we can understand that uniformity and variability of the data, how data is uniform and variable. And second thing is that through correlation we are able to understand that the relation between the data, there is in the perfect relation, there is in the imperfect relation, there is in the positive relation, or there is in the negative relation, or we can say that there is no relation. Through correlation we are understanding the relation between the variable, and the through regression we can understand how we can predict or how we can forecast dependent variable on the basis of independent variable. So for the forecasting we are using the regression, sometimes for the cause and effect relation we are also using the regression, and for understanding the relation between the variable we are using the correlation, and for understanding the uniformity and variability of the data we are trying to understand the dispersion. So these are the things we are going through this class. So thank you. Any question?